Hello all, this video is on DWIN HMI touch display with Arduino. In this video we will see how to send 1 and 0 from display to Arduino to control an LED, and also we will see how to display variable on the DWIN display. In this demo we have got 4.3-inch basic model resistive touch display with a resolution 480 by 270. This is very economical and effective. It has got TTL connections. We will be using RX2 and TX2 to connect with the Arduino. We have to solder these pins. At the back side you can see a metal case which is the T5L controller unit and a buzzer. At the bottom you can see a space for adding on Wi-Fi. This is for future videos. We require a micro SD card like this. Maximum up to 16 GB only is supported by the DWIN display. More than that is not supported. We need a card reader also. And an external power supply is required to supply 5 volt to the DWIN display. We will be using Arduino Uno, and then USB to TTL CP2102 module is also required to decode the hex code coming out from the DWIN display. Download the DGUS, that is the DWIN graphic utility software, from the official website. This is only a zip file. You have to unzip it, no installation required. You have to prepare the images and icons for your folder. It has to match the resolution of the display, and naming of the images should be 000102 like that. This is the list of steps to be followed in this demo. First you have to create a folder for your project with all the required images and icons. You can prepare the images using Microsoft PowerPoint, GIMP or any other software. The resolution should match the resolution of the display. Icons .png and images.bmp files. Naming should be 000102 like that. So the first step is over. Second step is open the DGUS software. Double click on the exe file to open the IDE and click on new. First you have to set the correct resolution of your display. Mine is 480 by 270. So set the resolution and then click on the file path of your project and click OK. Now the second step is over, and the third step is to create a font file using the word generator function given in the software itself. Click on welcome, and then at the bottom you can see the word bank generator. Click on the word bank generator. A separate screen will open. You have to adjust the horizontal and vertical scale to match the letters so that it displays properly on the screen, and then click on generate. It will take some time to generate the font file, and finally it generates a .hzk file on your folder where you started the software. You have to copy this file and then paste it on your project folder. Paste it inside DWIN_set folder. This folder is created when you create the project. So paste it inside this folder, DWIN_set. In this folder you have to store all the files. First we are storing the font file. Next we have to create the Icl files for images. Before that you have to resize the images. For this you can use the tool provided inside the IDE itself. You click on use the picture conversion tool to resize the images. At the bottom you can click on the link to open a separate screen. In this you have to first set the resolution of your display. Mine is 480 by 270. Set the resolution and then click on add, and then browse to the location of your project and add the images. In this project we have only 2 images. Add the images and then click on image conversion. Now the image is converted to the proper resolution of the display. Here it is 480 by 270. Once the images are resized, you have to create Icl file. For that click on setting and then DGUS to open the Icl tool, or you can click the Icl tool from the bottom of the display. Click on ICL tool and then click select pictures. Select your images and then click on open. We have got only 2 images in this project. Click on open and then click generate ICL. The selected images should be listed on the center of the window, and click on generate ICL. It will take some time to generate .icl file. That is a compressed file. You have to name the file as 32.icl. No other name is allowed. You have to just provide a name 32. This is the memory location of the image file that the software will understand. This file to be stored under the DWIN_set. So all files to be stored inside the DWIN_set folder, which will be copying and pasting into the SD card. Next we have to convert the icon images also. Select pictures and then select the icon images. Now store this images as 42.icl. This also to be stored inside the DWIN_set folder. So first we have created the 32.icl image folder and then 42.icl, which is the icon folder. And next step is to create the configuration file. For this, go to setting, DGUS. Here already we have done the ICL tool. Go to the next tab, which is the CFG edit. From under this tab you can do the settings like touch, sound on off, and then baud rate setting. By default baud rate is 115200. You can see the 115200, and you can also see the image file location, which is at 32. Already we have stored as 32 ICL. All configuration can be done from here, and buzzer on off, and orientation of the display can be set to 0 degree, 90, 270, 360, like that. Most important is the touch sensitive variable changes update, which you have to set it to auto, and then click on new CFG. Now you have to store this configuration file as t5lcfg.cfg. No other name is allowed. t5lcfg. If you want, you can put underscore and then give a name. And this configuration file to be stored under DWIN_set folder. All files to be stored under this DWIN_set. Now open this DWIN_set folder of your project. You can see the font file already we have stored, 32.icl, 42.icl icon file, and finally this configuration files. Now the next step is to add the images to the project. In the DGUS software, at the left hand side you can see a plus symbol. Click on the plus symbol and then add the images, which you have converted already to match the resolution of the display. In this project we have got only 2 images. Add on the 2 images. Now the images are downloaded into the IDE. We have got only 2 images. 0.bmp is the welcome page, and 1.bmp. The next step is to use the display and the touch control to configure the area of the displays. In the first image we have got only one location to define, that is the hand symbol. So click on the touch control and then page sliding and draw a box over the hand symbol. At the right hand side you can see the properties for the page sliding. Click on the set against the next page. You can see a preview window with all the pictures. We have got only 2 pictures, so select the second image, that is a 1.bmp, where it has to land. And then you can set the sliding mode to horizontal. You can also adjust the speed of the that is a touch sensitivity. Now the first page configuration, first image configuration is over. Go to the second image. We have got a variable display 1 and 0, and then a back image. First we will configure the back image. Go to touch control and then click on basic touch and draw a box against the back image. Go to the properties, set page switching, and then select the page to land, that is the welcome page 0.bmp. Next is the that is a text show. that is where you have to show the variable. Click on text show and then 1 2 3 data variable display, and draw a box over the area where you have to show the variable. To the right hand side is the properties settings for the data variable display. Most important is the VP address. This is the user defined address space on RAM for the variable. Total RAM is 128 KB. Of this 120 KB is user defined, 0x5000 to 0xFFFF. People give the VP address as 5000. This is user defined. And if you want, you can do the color setting, and then the word bank is 0, font size will set it to 40, and alignment is center, and variable type is 2 integers, and integer is 3 digits. Initial value of the integer is 000, that is initial display to be 00. So these are the settings for the variable display. Next is the 1 and 0 we have to configure. For this you use the touch control. Under touch control, click on return key code and then draw a box on 1, and again you click on the return key code and draw a box, another box on 0. First we'll do the settings for the property settings for the return key over 1. If you want, you can change the name here for return key 1. Most important property setting is to enable the data upload. Put a tick mark here so that when you touch on 1, a hex code is output at the detail pin TX2. The button effect and page switch we are not going to set here. The key value to return is 0x0001. So when you touch on 1, this return key value is output at TX2. Next we have to set the VP address. All variables you have to define an address. Provide an address as 5500 and select INT. Same way for the next return key code over the 0 display. Enable data upload, and then return key value 0x0000 and VP address to be same as that for 1, that is 5500. Select INT. And to the bottom of the 1 and 0 you have to display the icons, that is the LED on and off displays. For this, go to icon display, select variable icon display, and then draw a box below the 1 and 0 on the empty space. And the settings, you have to give the VP address as same as that for the return key code. We have given 5500, same VP address to be used here, so that any changes is reflected here. VP address is 5500, and then the icon file to be selected as 42.icl. We have created the icon file previously. For minimum, you set to 0 and then click on set and select the icon 0, and for maximum select 1, and icon ID, click on the plus symbol and select the second icon to display, that is a icon 1. Display is transparent type, filter set is 1. Now the property setting is over. Now click on the variable icon space to get the first icon, which is the LED off. Next you have to save the file. Go to file and then click on save, and finally click on generate. So the config file, everything is generated and stored to DWIN_set. To preview the project, go to display and click on preview from first page. So a preview window will open where you can see your project display. Here you can first image is displayed. You can slide on to the next page by using the page sliding thumb, and you can see the variable display, and then 1 and 0. Click on 1 for LED on and 0 to LED off. Double click to close. Now let us see how to format the SD card. You can use a card reader like this to plug in the SD card to your PC. Maximum supported capacity is 16 GB only. Plug in the SD card to your PC, right click on the proper folder and then select format. Click on format and then select the file system as FAT32. and the allocation unit is 4096 bytes. That is, the cluster size is 4 kilobytes only. If your SD card is only 8 GB, then you can select the default settings, which is nothing but 4096 bytes. But if it is 16 GB card, you have to select manually 4096. From CMD also you can give this command and format. Not more than 16 GB is supported. Once the card is formatted, drag in the DWIN_set folder onto the SD card. Now the project folder with all these files is copied onto the SD card. Now let us connect the power supply to the DWIN supply, ground to ground and 5 volt to 5 volt. Remove the SD card from the card reader and plug into the DWIN SD card holder. With power on, do not do this. Only in the power off condition you have to plug in the SD card. Now after inserting the SD card, switch on the power to the display. You can see the files being downloaded. All files are being downloaded. The .hzk, that is a font file, will take some time. Once the files are downloaded, you can see the configuration plus symbols. Touch on the plus symbols as they appear. On all 4 corners it will appear, and then finally in the center you have to correctly touch the plus symbol, otherwise the configuration will change. Once the configuration is over, switch off the power, remove the SD card, and then switch on the power. Now you can see the project being executed on the display. First page, there is a page slide. Slide it to go to the second image. There is 1 and 0. Touch on 1 to display the LED on icon, 0 to display the off icon. Now let us connect the display to USB to TTL device with the CP2102 to decode the hex code. For this we have to do the connections at the TTL connection, that is RX2 and TX2. We are not using TX4 and RX4, only RX2 and TX2 used. RX2 goes to TX of CP2102, TX2 goes to RX of CP2102, and ground to ground. The connection is simple. Now plug in the USB to TTL to PC, and then open the CoolTerm terminal software. This is a nice terminal software. Click on options, and then click the port which is allotted to the USB to TTL device. If port is not allotted, just click on rescan serial ports and then select the port. Set the baud rate to 115200, which is the default baud rate of the DWIN display. Now click on view hex and then click connect. Now from the display, touch on 1. You will get a series of hex codes. Let us decode it. 5A5 is the header, and 06 is the total bytes received, and 83 is for read, and then the VP address. 5500 is the VP address, and the data is 01 bytes, that is 2 bytes, 01 word, 2 bytes, 0001. Touch on 00, you will get 0000, and 1 will give 0001. So this is the hex code we are getting. For sending the variable, you click on connection and then send string. Now select the hex and then type in the hex code without any space. 5A5 is the header, and 05 for receive we are getting 06, but for transmit only 05. That is 5 is the number of bytes, and 82 is the code for write. And then the VP address 5500, that is the VP address we are going to write. And then the data is 000A. A means in hex, in decimal it is 10. So you get 10. Now let us change the data to 0F. You get 15015. Let us change it to 0102, which is equal to 258 in decimal. Change the data to 0102 and then click on send. That the hex is 0102. For decimal it is 258. So it is displayed in decimal. So we are able to display the variable like this. Now let us connect it to Arduino Uno. The connection is same, that is TX to RX, RX to TX, and ground is common. RX is connected to TX2 of display, TX is connected to RX2 of display, and ground to be common. That is very important. Now let us provide the power supply 5 volt and ground to the display, and then let us connect an LED at digital pin 10, and the other end of LED is connected through resistor to ground. So ground of Arduino and ground of display both should be made common. This is very important, otherwise the data will not be transmitted. Ground is made common. Now let us switch on the power. We have already uploaded the Arduino code to check for 1 or 0, and then switch on the LED connected at digital pin 10. So touch on 1, LED at digital pin 10 is on, and touch on 0, the LED connected at digital pin 10 is off. Now let us see the code. In the Arduino code, initially we define an array variable of size 9. Array variables are 0 indexed. This array variable is of type char. So we are getting the array from the DWIN display, that is a hex code array. We will be analyzing it and then switching on the LED on or off. LED is connected at digital pin 10, so we declare it as int LED equal to 10. And then under void setup, we serial.begin at the baud rate of 115200, and initially the LED is off. And under void loop, we check for the serial data. If serial dot available, then we iterate using the for loop, that is 0 to 8. As you know, arrays are 0 indexed. We iterate from 0 to 8, and then we assign the serial dot read to the buffer. So check for the index 0, that is a buffer 0, whether it is 5A header. If header is okay, then we use the switch statement to check the buffer 4, that is the index 4, which is VP. Now check for the VP address, that is a high byte 55, and then using the case statement, we check for the whether it is 55, that is the VP address is 55, and then go to the buffer 8, that is the index 8, which has got the data. If it is 1, we use the digital write to switch on the LED. We make the digital pin high to make the LED on. And if the buffer 8 is 0, if it has got the value 0, then we make the digital write low to make the LED off. So this is the code. You just select the Arduino port and then upload the code. Do not forget to remove the RX and TX pins wires before uploading the code. If pins are RX and TX pins are connected, then you will get error. Now upload the code and then check. If you touch on 1, the digital pin 10 is high, LED is on. Touch on 0 to make the LED off. So the code is working now. Now let us see how to display the variable on the variable data. For this we will be using a byte array. We declare a byte array. We declare a on LED variable array of type byte, and the data is hex data 5A A5, which is the header, and 05, there is a number of bytes we are going to send, and 82 is the code for hex code for write, and 5000, that is a VP address we are going to write, and then finally the data. For on LED, the data is 0001. So this is the hex data we are going to send. Same way for off LED, we declare a byte array, and the data is 5A A5 05 82 5000, and then data is 0000. We use the serial.write function to write the hex, that is a variable name, followed by the number of bytes. So the total number of bytes we have declared is number of bytes is 8. Do not confuse with the index of the array. This is 8. So total number of bytes we are going to write. So use the serial.write and the variable name comma number of bytes. Same way for the LED low also, we'll use serial.write LED off, comma 8, and then upload the code. We are getting here error. So the variable name we have misspelled. You change it to on LED and off LED. Now click on upload. Before uploading, remove the RX and TX OS. Once uploaded, connect back the RX and TX OS. Now touch on 1. You can see the variable also displayed. LED is on, also the variable is displayed on the display. Thank you for watching.